Good morning.
Good morning, sir.
Good morning, sir.
Good morning.
Good morning.
Good morning, sir.
What was the last thing we covered in the previous class?
One rotation question where this rod is pivoted at a point and there is a spring attached to the ground on one side and a string attached to the point or ground on another side, and then the string is cut.
Okay, we have learned how to take the torque equation.
Yes, sir.
Yes, sir.
Preferably, it should be about the center of mass of the body.
Or a
If
non-accelerating frame.
Non-accelerating.
If not a point which is not accelerating. Last but not the least, suppose you are forced to take the torque about an accelerating point, you should
Apply
not
pseudo
forget
force.
the torque due to.
Pseudo force.
Pseudo
That has to
force.
be applied on center of mass.
There are 4 problems in your booklet which I solve in the class regularly for the students to make this more clear.
Have you received that offline any intimation what the schedule will be?
In fact, I was out of station for 2 days. I'll be going to Andheri today, but even then,
Oh, okay.
last 1 week only we'll have a clear idea on the timetable. Offline ka will start from March 1st, right?
Yes, sir.
So probably Monday, Tuesday, it will take shape.
अच्छा होगा सर ये बहुत ज्यादा इतने देर के बाद फाइनली.
Second exercise 5 of the booklet. 1 second, I'm opening the exercise 5. Can you see the 10th question?
Yes, sir.
Yes, sir.
I'll give you 2 minutes. Will you attempt?
We will try.
Yes. 10th question, exercise 5 of your booklet. 10th question, exercise 5 of your booklet. Basically, a direct application on the concept of how to take the torque equation.
So,
Hmm.
sir, a force acting along the length of the rod can't produce any torque, right?
About
About the center of mass.
obvious.
Okay.
Are you people solving?
Yes, sir, yes.
Yes, sir.
Sir, is the answer 5G by 3L?
So, पहले का I'm getting 3G upon L. Angular acceleration.
by
10th question, right? I don't have the answers yet. You will have to verify.
Okay, sir. So, when you solve it, only we'll check.
Okay, not an issue.
Three G by L is the answer. No?
I don't know. I'll also have to solve.
Okay, sir.
Just little bit more, sir, on option C.
Right, right. I'm waiting. No hurry. The problem is a good one. Please attempt sincerely. Shall I?
Oh, sir, 1 second.
सर खाली सी पार्ट का आंसर कुछ और
So for this C part, when we are taking the tangential acceleration, that will be in the downward direction, right? With respect to the center of mass.
Hmm.
Oh, yeah, sir. Then done.
Have a look. 10th question. This is an important question when it comes to the perspective of taking the torque equation. This will be Kx, this will also be Kx, identical springs.
यस सर
So if this is theta, it will be Kx sin theta. So first equation is 2Kx sin theta is equal to mg. Initially, when the system is in equilibrium, this will be sin 30 and 2 will get cancelled. Kx is equal to mg. First bit of information before this spring is cut. Once the spring is cut, this Kx will become 0. Now, what are all the forces acting on this particular body? I will have Kx sin 30 here. I will have Kx cos 30. And this will be mg. Kx sin 30 and this will be mg. Right?
Yes.
Yes, sir.
Now, what do they need? Angular acceleration of the bar A, B. Angular acceleration of the bar. Alpha I should get. Alpha to get, I'll have to calculate the torque.
Oh, yes, sir.
Torque I'll take about which point?
So center of mass.
सेंटर ऑफ
Here I know point A is accelerated. What gives you that instinct that point A is
So
accelerated?
there's a force acting on it.
Horizontal force. hai.
Yes, sir.
Vertical force VB is getting cancelled out. K sin theta and mg, but horizontal cancel करने के लिए कुछ है ही नहीं.
Yes, sir.
100% my intuition should tell me that point A is accelerated. और अगर point A पर torque लेना है तो pseudo force लेना ही पड़ेगा.
Yes.
So to avoid that controversy, I take the torque about center of mass. Kx cos 30 is passing through the center of mass, mg is passing through the center of mass.
स्क्वायर बाय 12
Kx sin 30 into L by 2 is equal to ml square by 12 into alpha. Talk about the center of mass.
Yes, sir.
Talk about the center of mass is ml square by 12. Kx value you know is mg. mg L by sin 30 is half. I have a half here. This will be ml square by 12 into alpha.
यस सर
3g by L is alpha. First bit, I believe quite a few people could do this. I'm happy about it. 1 second, wait.
सर वापस बैंक वालों का कॉल आया था.
Are you able to hear me?
Yes, sir.
Yes, sir.
Done, sir.
Done, sir.
Now, you want acceleration of point A with respect to center of mass plus acceleration of center of mass with respect to ground is acceleration of point A with respect to ground. Acceleration of point A with respect to center of mass plus acceleration of center of mass with respect to ground. Shall we do it first along x-axis or y-axis? First, let me do it along y-axis.
Right.
Now you have taken alpha this way. I will redraw the diagram here. You have taken alpha this way. This will be L by 2 alpha with respect to center of mass. L by 2 alpha with respect to center of mass. But did you calculate alpha? You have calculated alpha. Center of mass acceleration, did you calculate? No. Right? You did not calculate the center of mass acceleration in the y-axis. Alpha, how much did you calculate? 3g by L. Now, center of mass acceleration will be mg minus kx sine 30 is equal to m into a. Agreed?
Yes,
Yes, sir.
Translational dynamic equation. Alpha, you got it directly from rotational dynamic equation. Here it is translational dynamic equation. mg minus kx, how much did you get?
mg.
G.
So
by
mg
2.
by 2 is equal to m into a. A is equal to g by 2. A is equal to g by 2. Acceleration of A with respect to center of mass in the upward direction del by 2 alpha minus g by 2 is acceleration of A with respect to the ground along y. Alpha is how much? 3g by L minus g by is acceleration of A with respect to ground. Now this should not be difficult. 3g by 2 minus g by 2. Acceleration of A with respect to ground along y-axis is g. Do you agree with this?
Yes.
Now job is not done. This is acceleration of A along y-axis. X-axis we calculate karna hai. Are you able to see the left part of the board here?
Yes. Yes, sir.
Acceleration of A with respect to center of mass plus acceleration of center of mass with respect to the ground is acceleration of A with respect to the ground along x-axis as well. Acceleration of A with respect to center of mass. Acceleration of A with
zero.
center of mass is 0. क्या
Rigid
यार
body.
centripetal acceleration हो सकता है ना यार भाई साहब omega is 0 initially. Acceleration of center of mass with respect to the ground in the x-axis is kx cos 30 by m. I'll get the acceleration of A with respect to ground. Acceleration of A with respect to ground along x-axis is kx is mg. mg root 3 by 2m. This will be g root 3 by 2. This is along x-axis, this is along y-axis, depending on how he reports. If he reports it along I cap, j cap, इसके बगल में I cap लिख लो, इसके बगल में माइनस j cap, इसके बगल में
Yes.
माइनस j cap, इसके बगल में I cap.
Positive.
Right? Because this is in the downward direction. Who told you this is in the downward direction? आपके डायनेमिक इक्वेशन नहीं बताया. mg minus kx sin 30 लिया. So I cap j cap ढंग से देख लिया. And that why I'm telling you that is he showed in the diagram x and y clearly. He told you this is x, this is y. So acceleration in the downward direction I will have to put minus j cap.
So
हाँ.
So can you please again explain how initially centripetal acceleration is 0?
Omega is 0. When you cut this, there's no omega. You have dropped the body at that instant. What will velocity be?
0.
Zero.
Oh, right, yeah.
I will be
mv
zero.
square by r.
Sir, omega about x-axis is 0. That's why alpha about x-axis is 0.
Omega of the body is zero. Rigid body theorem doesn't permit you to say omega about this point of the body, that point of the body, about any point will be the same. Isn't it?
Yes, sir.
Angular velocity of Earth, whether you are standing in India or on US or on the North Pole, will be the same. Time period will be 24 hours. We dealt with that, yes or no? So when omega of the body is zero, angular velocity of any point of the body with respect to any point of the body will be zero. So omega square r, which is centripetal force, will be zero. Can I rub the board?
Yes, sir.
Now acceleration of B on the same lines. along the x-axis, along the y-axis. Acceleration of B with respect to center of mass along y-axis plus acceleration of center of mass with respect to the ground along y-axis is acceleration of B with respect to ground along y-axis. This was alpha. So this will be L by 2 alpha downward direction plus acceleration of center of mass is G by 2 is equal to acceleration of B with respect to the ground along y-axis. L by 2 alpha is 3G by L plus G by 2. Acceleration of B with respect to ground along y-axis. This will become 3 plus 1, 4G by 2 is 2G is acceleration of B with respect to ground along y-axis. Downward direction minus J cap.
Yes.
Now along x-axis, acceleration of B with respect to center of mass along x-axis. Have a look, same logic. Acceleration of B with respect to center of mass along x-axis plus acceleration of center of mass with respect to the ground along x-axis. Should be acceleration of B with respect to the ground along x-axis. And this will be acceleration of C with respect to the ground along x-axis is kx sine 30 by m. So we get this particular value. Will you try the next problem?
Yes, sir.
Now here there are 3 bits in this problem. "20-second question. Is it visible?
Yes, sir.
20-second. All 3 bits.
Pilani, Goa, and Hyderabad.
I'll wait for you.
So what's the third part? Or is it only A and B subparts?
only A and B.
Okay.
All of you are solving the problem, right?
Yes.
Yes, sir.
So,
Hmm.
so can you explain what the difference will be between the pin and the wire?
Hinge
Wire
force.
is flexible, pin is hinge. Wire can swing.
So, sir, in the first case, we can take torque along A, no?
Perfect. About the hinge you can take, and it is suggested that you take the torque about A.
And then apply parallel axis theorem and solve.
Right. Shall I solve the first one?
So can we like solve all of the three parts and then?
Yes.
You said you want to take time to solve all three and then discuss?
Otherwise,
Yeah.
we will. Oh, yes, sir.
Sir, otherwise you will solve one part, then you'll copy that solution and then we'll go to the next part. So
Okay, I have no problem either. First bit. So I'm discussing the first bit. Shall I stop the screen share?
Yes, sir.
Yes, sir. Yes, sir.
First bit basically 22nd. There is a pin here. Pin is more like a hinge. More like a hinge. There will be a hole here, a hole here. How do they hinge it? They'll hinge it this. They'll send a rod in between. So it gets hinged. Right? That is more like a pin. Now, pin ka biggest advantage is that point will not accelerate. That point will not accelerate. And if I try to take the torque about center of mass, I have a small issue. This will have Nx and Ny. Two components hoga. Ny is balancing weight. Nx also will exist.
Yes, sir.
Like a
yes.
rod sending through a hole. I press it to the right, normal force is to the left. I press it to the left, normal force is to the right. So the Nx will exist or not also I don't know. Actual direction of normal force here I don't know. I will know in the next class. So risk any kind. If I take the torque about center of mass, I'll have to take the torque because of the x component of the normal force and y component of the normal.
Yes, sir.
So you cannot take the risk. Take the torque about A. Take the torque about A. What did they ask? Angular acceleration of the plate. Torque about A is mg into this distance. That distance is c by 2
See, by
is equal to I about A into alpha. I about A is I about C plus m into d square into alpha. What is d? This will be d.
Yes.
I about C is this. Parallel axis theorem. Parallel axis
Okay,
theorem.
we solve
I
it.
about C plus m into d square. What is I about C? M C square by 12 plus m C by 2 whole square by 12 into alpha. This is mg into c by 2. ml square by 12 plus mb square by 12. So first part
So
of the
plus
problem is
md square also, sir.
d is c by 2.
So how will d be c? So d
C
you have to
by
calculate
2
using Pythagoras.
Pythagoras theorem.
Pythagoras theorem. It's okay. You calculate d. Not
So,
difficult.
but what the other two will still remain, no? Because that is IC. This is a rectangle. So perpendicular axis theorem.
C by 2 whole square. This is IC plus m into d square. This into R. This is IC. Right? I about C is ml square by 12 plus mb square by 12. bc by 2, L is C plus md square. Right? Great. Now how do you calculate d? Should not be. This is C by 2, this is C by 4. D square is C by 2 whole square plus C by 4 whole square. Say something.
So can
Yes,
you
yes,
explain
sir.
that change you made?
Yes, sir. हाँ,
So can you explain that change you made right now?
This
In
is
this
I
one-
about C. I about C. C symbol is being used many times. I'll call it O. This is I about O. Rectangular plate ka what is I about O? ML square by 12 plus MB square by 12.
Yes, sir.
Yes, sir.
This is I about O plus M into D square. I'll get the moment of inertia about it. Agreed?
Yes, sir.
Yes, sir. Yes, sir.
Now, have a look at it. Something tricky. Acceleration of its center of mass पूछा गया है. So now you will be firstly tempted to write the translational dynamic equation. Don't. You know the value of alpha, right?
Yes.
Equation से alpha आएगा कि नहीं?
आएगा.
I know.
आ जाएगा.
This will be B alpha, R alpha, alpha into D. R alpha about this particular point. Yes or no?
Yes, sir.
Body is turning this way. R alpha will be perpendicular to R. What is R here? D.
Yes, sir.
Yes, sir.
Acceleration of O with respect to A plus acceleration of A with respect to ground is acceleration of O with respect to ground. Do you agree with this?
Yes,
Yes, sir.
sir.
Acceleration of O with respect to A. Acceleration of O with respect to A. This is alpha D. Right?
Yes, sir.
Plus acceleration of A with respect to ground is 0. Will be acceleration of O with respect to ground. This alpha you substitute here, you get this. If I want to report in terms of y-axis and x-axis, should not be difficult for you. This problem can be solved. Generally, translational dynamic equation, rotational dynamic equation, and constraints. They'll give you 3 variables. Here they didn't give you 3 variables. So, दो variables, दो equations से काम बन गए. यहाँ directly alpha you got, here you will get ACM. The direction of the acceleration of center of mass is like this. If he reports in terms of I cap and J cap, you will be able to resolve this along I cap and J cap, both negative. Yes or no?
Yes, sir.
Yes, sir. Yes, sir.
Shall I share the screen for the next question?
So one.
Sir, EM paper के लिए thank you.
हाँ, sir. अरे.
Welcome.
थैंक यू सर, भूल ही गए थे सर।
में कुछ नहीं आता था ये
EM is a scoring paper. Next year boards के लिए ढंग से तैयारी कर लो. Boards will not be online. Boards will be offline.
हाँ
सर
सर,
तब तक तो
पता चल
फिजिक्स
गया।
में कवर हो जाएगा ना ये सब।
हाँ, करंट इलेक्ट्रिसिटी वो सब हम 12th में कवर कर देंगे तो थोड़ा बहुत आसान हो जाएगा, मगर फिर भी कॉशन, केयरफुल. इट्स अ वेरी स्कोरिंग पेपर. 98 99 हर किसी को आता है. 95 आ गया मतलब बहुत खराब परफॉर्मेंस.
सर स्टूडेंट्स यूज्ड
सर
टू गेट
मोटर भी
200 on
पढ़ते हैं क्या हम
200
लोग?
ना in EM. Sir, students used to get 200 on 200 in EM na.
200 and 200. That's what I'm telling you. 98 percentile, 97 percentage in EM is very common. 95% आ गया मतलब ओके ओके बहुत खराब गया पेपर, तब 95 94 आते परसेंट. Problem with you people is you people show a lot of attitude to the college faculty. That's why they also feel very irritated. कितने बार समझाता हूँ, हाथ जोड़ के खड़े रहो यार उनके सामने. अब प्रैक्टिकल्स का इंटरनल मार्क्स सारे उनके हाथ में, कि कहाँ तक जबरदस्ती करेंगे हम लोग उनके साथ. उनको भी दिल से देने का मन कर रहा है. सही बोला कि नहीं? आप लोग जबरदस्त एटीट्यूड दिखाते हो उनके साथ प्रैक्टिकल्स में. अब वो लोगों को becomes very difficult to bridge the gap between you both people. Yet they make sure that your people get 98 99 हर भर के परसेंटेजेस मिलते हैं यार.
You have not shared the screen.
Is the screen visible?
Yes, sir.
Second, wait. Tell me when I can discuss it. People who are not attempting, you are missing on something very important. When I am taking the doubts of rotation booklet, you ask me these questions, I'll hang you upside down. Please attempt. You are given time in the class. On your own at home, you will not be comfortable attempting this problem. They will turn out to be doubts.
ये केस में भी सेंटर ऑफ मास नहीं ले सकते ना, और
ले सकता है ना.
Center of mass पर ही लेना है. Point A may be accelerating. Point A may be accelerating. ध्यान से देखो, ढंग से देखो. That discretion of taking the torque about center of mass is important here. I'll just be back in a minute. Don't make noise. Attempt this problem.
So,
Are you people solving?
Yes, sir.
yes, so. So, I have not rubbed what was written on the board right, in the previous
Okay.
one.
Oh,
Acha. Sir, anyways, it's a very small doubt that I had. Sir, when you're discussing the next sum, sir, I'll ask that.
okay.
The answer I have, but I am not sure if it's correct.
I also don't know the answers because इस PDF में सिर्फ exercises हैं. Answers मेरे पास नहीं है. You'll have to wait.
So will we get homework today?
Political I
Thank
will
you,
be
sir.
उसके बाद में.
Done, sir.
Please solve. Yes, sir, you can solve.
Now listen. This length is C, this is C by 2, this will be mg, this will be T. Right. mg minus T is m into A. Translational dynamic equation. Right. T into, you are taking the torque about center of mass. This distance is C by 2. T into C by 2 is I into alpha. I is about the center of mass. mc square by 12 plus m into c by 2 whole square by 12. ml square by
So
12.
perpendicular axis theorem, right?
No.
Moment of inertia.
Moment of inertia of
Rectangular plate.
rectangular plate about
Yes,
this
sir.
axis is ml square by 12 plus mb square by 12. L is c, b is c by 2. About the center of mass. अपने about the center of mass we had perpendicular to the plate. So I about C perpendicular to the plate passing through the center of mass is I check ml square by 12 plus nb square by 12. No parallel axis, no perpendicular axis. I'll call this particular point A, rather he only called in that O. Acceleration of point A with respect to center of mass. ध्यान से सुनिए constraint relation. Acceleration of A with respect to center of mass. Center of mass I am taking as O. Plus acceleration of O with respect to ground, which is A, will be acceleration of A with respect to ground. Right? This will be, if I take this to be L, this will be L alpha and this will be A downwards. L alpha, A downwards. In दोनों का resultant I should resolve along the vertical direction and equate it to 0. Resultant of L alpha, acceleration of A with respect to O is L alpha. Acceleration of O with respect to ground is downwards. That means इस A का L alpha का resultant I will have to resolve along the length of the string and equate it to 0. Agreed?
Yes, sir.
Instead of taking the resultant and resolving, I will resolve and take the resultant along the y-axis, along the y-axis, along the y-axis. Acceleration of A with respect to ground along y-axis should be 0. Acceleration of O will be minus A. This will be, if I can find out this theta, this will be L alpha cos theta. L is this distance. L alpha cos theta should be 0. This will be my third equation. Three equations, three variables, A, alpha, and T. He didn't ask for tension, so eliminate T. A and alpha is what they asked.
So I have a silly doubt. Can I ask it?
Bolo, bolo, bolo.
So over here, point A, there's tangential acceleration L alpha, right, at an angle theta.
Tangential acceleration L alpha, right?
Yes, sir. So that tangential acceleration, it will have some component along the x-axis also, right?
Perfect.
So then why are we not considering that x-axis part for point A?
We are. That's the reason why I know that point A is accelerating and I didn't take the torque about point A. If I would have taken torque, I'll have to put that L by 2 alpha or L alpha's horizontal component as to the force.
Okay, sir.
I pretty well know that I have a horizontal acceleration. That's why I didn't take the torque about it.
Okay.
Second, constraints में क्यों नहीं लिया आपने?
Yeah, that I understood.
Constraint should be this point and this point should have the same acceleration along the length of the string.
Yes, I got it. So then in the final answer, when we are reporting acceleration of A, we have to give the x component also, right?
Naturally,
Okay, sir.
अगर acceleration of A पूछा हुआ है, तो x and y, I cap, j cap दोनों लिखना पड़ेगा और magnitude as specified.
So here we equated to 0 and in the spring we equated to elongation, right? X.
Yes, sir. No.
If you are applying constraints, you will equate it to elongation. Basically, if this moved by a distance of x1, this by x2, x1 minus x2 is the elongation. If it is a string, I equate it to 0. If it is a spring, I equate it to that elongation.
Yes.
सर इस सम में मैंने एक्चुअली L alpha cos theta के बजाय डायरेक्टली रिटन L alpha into c by 2 गलती से द परपेंडिकुलर डिस्टेंस और
Yes, sir.
कोइंसिडेंटली आंसर भी
हाँ
करेक्ट
सर आंसर आ गया
sir.
सर मैं 5 मिनट ये सोच रहा था कि मेरा आंसर करेक्ट क्यों आता है बट इट्स बिकॉज cos theta का वैल्यू इज ओनली c by 2
Answer. That cos theta's value, he adjusted it properly. Can I stop the screen share? Oh no, the board is visible for you. Can I start the screen share for the third bit?
So 1 minute.
Sir, I have to ask something. It's not related to this. Can I?
Follow.
Sir, you have a doubt lecture tomorrow and you said you'll reschedule it. Goes tomorrow. Like you said you'll reschedule it today.
Today तो नहीं होगा. In fact, I was traveling last 2 days and very tired today. Today lecture लेना भी मुश्किल हो रहा है. It's like I'm waiting and seeing how much more time is left. Right. Today I'll not be able to. But today is Friday or Saturday.
Today is Saturday and tomorrow you have a doubt lecture 11 to 1 with us.
तो अभी डाउट्स ले लो ना आधा घंटा है तो
What all doubts should we take?
एक्सरसाइज 1 to 20 sums of
रोटेशन
Question
के
1
आपने
to 20.
20 सम दिए थे
Tomorrow evening can we schedule?
यस
Okay.
But I'll leave a message tomorrow morning for you people in the group. Janet 1, right? I will be going to Andheri office today evening. I'll have a word with Gautam if he has scheduled any doubt lecture or not, because timetable me he is aware of that confusion. So I'll have a word with him and leave a message to you. Can I go to the third part of the problem?
Yes, sir.
Third bit, I'll give you a hint. Problem is easy. I'm not joking, I'm serious. Problem is easy. Third bit, problem is easy. Remember that. And I'm not joking. मैं मजाक नहीं कर रहा.
Sir,
Ah,
sir, here we take the real distance between A and O, and not just the perpendicular distance, right? Like, but sir, we did a problem where a rod was
we are
inclined at
2 points. Real and perpendicular का सवाल कहाँ है? This is O, this is A. Distance between them एक ही होगा. Axis के बारे में क्यों सोच रहे हो? Distance is
नहीं सर, पर हमने एक प्रॉब्लम किया था ना जिसमें the rod was inclined at an angle theta, and we did not take it as L/2. We took it as L/2 cos theta because that was the perpendicular distance between.
कितना कंफ्यूजन क्रिएट कर रहे हो अपने आप के लिए जिंदगी में. सुनो, वहां पर आप कौन सा इक्वेशन के बारे में रेफर कर रहे हो? You need the distance for one equation. Which among the three?
Sir, this हाँ अरे हाँ I alpha. Yes sir.
Torque equation?
Yes sir.
हाँ, torque equation कैसा लेते हो आप? When you took the torque about center of mass, extend the line of action of tension and drop a perpendicular. How much is the perpendicular distance?
L/2 cos. हाँ L/2.
Right?
Yes.
Now in that problem, when you are able to see this part of the road.
Yes sir.
Now in that problem, when I am taking torque about center of mass, extend the line of action of the force and drop a perpendicular. What is the perpendicular distance?
L/2 cos theta. Yes sir.
See how much of a confusion you are creating for yourself. यहाँ cos theta क्यों लूँ भाई साहब? Extend the line of action of tension, drop a perpendicular. This distance is already given to you. If this distance were given, then I will resolve this L along this direction. मुझे वो perpendicular distance चाहिए. आप कैसा कैलकुलेट करोगे? अगर दिया हुआ है ऑलरेडी as c/2, मैं L से क्यों रिजॉल्व करूं?
हाँ सर. हाँ.
दूसरी बात, जब आप R अल्फा की बात कर रहे हो, यहाँ पर this is L/2 alpha.
Yes sir.
This I resolved in this direction with respect to center of mass. -8 should be equal to 0.
Yes sir. Okay, got it.
Can I rub the board?
Yes, sir.
Problem is quite easy. Have a look at this. First of all, this kx and this kx will be equal to mg. So 2kx is equal to mg. Kx is equal to mg by 2. Now acceleration of center of mass of this particular plank is mg minus kx is equal to m into a. When you cut this is a spring. Spring का main characteristic is instantaneously its acceleration will not change. Yes or no?
Yes.
So m into a, you know the value of kx, mg minus mg by 2 is m into a. और क्या चाहिए आपको जिंदगी में? इससे आसान कैलकुलेशन कहाँ होगा? Right. Take the torque about center of mass. What is this distance? This distance is c/2. This is kx.
Yes.
Kx into c/2 is I into alpha. Kx का value कितना है? mg by 2 c/2 is I is mc square by 12 plus mb square by 12 into alpha. एक ही इक्वेशन एक ही वेरिएबल. I about center of mass mb square by ml square by 12 plus mb square by 12 and kx का वैल्यू पता है. Isn't the problem very easy?
Yes.
Yes, sir.
Yes, sir.
Sir, if we visualize this, the spring, when the plate is attached to the spring will be stretched now. And then when the spring is cut, the other spring will also will remain stretched only.
डाउट क्या है?
नहीं सर, वैसा visualize it.
आप जिस spring, which spring are you trying to visualize? The one which is cut or this leftover?
Sir, the leftover.
When you cut this instantaneously, the position of this will not change, right?
Yes, sir.
So kx is the same.
Yes, sir. Understood.
Can I proceed?
Yes, sir.
Now listen. Generally, I solve this while moment of inertias are being solved. In your case, I forgot to do that. I solved this with moment of inertias. भूल गया था मैंने आपके बैच में. Please solve the 23rd. This is not something to do with torque equation. Don't scratch your head and try to find a torque equation for this. So moment of inertia पूछ रहा है आपसे. देख लो, a tricky question. People will have this as a doubt.
सर डेंसिटी तो kg का मीटर क्यूब रहता है ना सर, मीटर स्क्वायर कीजिएगा.
क्या टाइपो है?
So you were saying
वो
mass
area-
density is
area
unit
density है.
kg per meter square instead of meter cube.
वो plate है. That's a plate. मास पर यूनिट एरिया ही डिफाइन होता है, यूनिट्स ऑलवेज देख
मतलब
लिया करो।
sigma, they have given sigma is equal to that.
Instead of sigma, they gave it as rho. It is derivation. This understanding of lambda, sigma, and rho is between you and me. Paper setter can call rho to be mass per unit area. There is no hard and fast rule that rho
okay,
should be
sir, got
only
it.
mass per unit volume.
Sir, थोड़ी
Shall I?
sir, please.
So,
Hmm.
so we have to solve this using calculus only, no?
Obvious.
Okay, sir. So, and so then the element that we consider, so will that be a strip?
Yes.
Okay, so then just give a little bit of time. And here A is a constant, right?
A is a constant. Have a look. Y equal to x square. That's the way the plate goes. This is x equal to A. Agreed?
Yes, sir.
You are asking me moment of inertia about this axis. Consider an element at a distance of y of thickness dy. Of thickness dy.
Sir,
Ah,
so in this, can we consider an element which is perpendicular to the element you have taken?
you can, no problem. Di, every part of this element is at the same distance of y, dm into y square. Every small element you consider is at the same distance of y from the x-axis. So dm into y square, sigma of mi, ri square. Right? So rho into Rho is mass per unit area. Into this area, what will this be? A minus x into dy. A minus x into dy. This will be dm. See if you are convinced.
Yes, sir. And you can calculate dy with the equation that they have given.
Back into y square. This is your moment of inertia. Integral di. Rho a y square dy minus rho x y square d. Am I right? Now y is equal to x square. dy is 2x dx.
Yes, sir.
Can I substitute dy as 2x dx?
Yes, sir.
Is a different thing. dy as 2x dx. Y is x square. That means this will become x to the power 4. This will also become x to the power 4. dy is 2x dx. Least value of x is 0. Maximum value of x is. Did we
ये
convert
पूरा
into
चमक
x?
गया था, बस 2 मिनट और देते तो हो जाता.
We integrated with respect to x, right? Suppose if you would have kept it as y.
Put x in terms of y.
हाँ सर तभी हो जाता.
Minus a2 minus to plus लेना पड़ेगा. Minus y to plus y.
समझा नहीं क्यों?
तो मतलब माइनस ए स्क्वायर से प्लस ए स्क्वायर तक ना, क्योंकि y इज इक्वल टू एक्स स्क्वायर.
हाँ माइनस एक्स स्क्वायर है इसलिए यहाँ पर.
Oh yeah. So converting it in terms of x is the safest bet, right? Least value of x. Don't you think the final answer here should be multiplied by 2?
No, sir, it will be the same only.
अरे भाई नीचे का मास तो लिया ही नहीं हमने.
सर
इस इंटीग्रेशन में कहीं पर नीचे के मास अकोमोडेट हुआ?
नहीं सर.
नहीं, sir.
So final answer should be multiplied by 2.
Oh,
Okay, sir.
The limit will be 0 to a square ना, and then we'll multiply it by 2.
अरे भाई x का you are integrating with respect to x. Least value of x is 0. Maximum value of x is a. अगर y करते तो a square लेते, x is a. We are integrating with respect to x. X का least value is 0. Maximum value is a. Final end result को 2 times इसलिए multiply करना है because lower mass लिया है. The next topic we need to introduce is kinetic energy of the body subjected to pure rotation, translation, so on and so forth, which I will do in the next class.
Thank you, sir.
You will get homework also after the next class only, right? Doubt lecture for tomorrow, I'll keep you people informed. Today evening, when I go to Andheri office, I'll give a message to the people. Is that clear?
Extra problems are moment of inertia, finding of momentum.
मिलेगा, कंबाइन कर दूंगा उसके साथ. उसके लिए टाइपिंग करवाना है, करवाऊंगा.
Yes, sir.
Sir, you live in Andheri only, na?
I live
सर 1 मिनट
10
साइड जा
minutes of
सकते
a
हैं?
drive from Andheri office, DN Nagar Metro. Right.
सर 1 मिनट थोड़ा साइड में जाओ ना। डन सर।
So फिजिक्स के हेड ऑफ डिपार्टमेंट आप ही हो ना?
क्यों डाउट क्यों आया तुम्हें?
नहीं सर, बाकी सब्जेक्ट्स का पता है सर, फिजिक्स का ऐसे डेफिनेटिवली नहीं पता।
अगर बताऊंगा तो पार्टी मिलेगा।
अरे नहीं सर, बस
सर
ऐसे
आप
general
हमें
knowledge।
पार्टी दोगे ना, आप हेड हो।
भाई, मैं क्यों दूंगा?
सर आप हेड
अभी
हो।
अगर
इतना
आपके पास
Bitcoin पड़ा हुआ
इंफॉर्मेशन है, एडिशनल इंफॉर्मेशन दूं आपको और पार्टी भी नहीं?
सर दे दो सर, आपके स्टूडेंट्स हमें नहीं दोगे तो किसको दोगे?
हाँ सर।
Yeah, I am.
सही है सर।
Ironically.
सर बट सर मुझे सर कैन आई चेंज द सेंटर बोरीवली सर, क्योंकि फैकल्टी चेंज हो रहे हैं बोरीवली में ऐसा।
तो अंधेरी आओगे कैसा? बहुत सारे बच्चे करते हैं, बोरीवली से आते हैं, मगर अंधेरी अभी आओगे कैसा? ट्रेन में आओगे?
हाँ सर
ट्रेन में अलाउड नहीं।
अलाउड है
दो
सर, 2
allowed.
वैक्सीनेशन हो गए।
To take a decision, wait for 1 week, because what we are planning there is those students who want to attend online with the previous faculty, उसके उन बच्चों के लिए some will be attending from house, some will be attending from the campus. You will go to say Borivali Center, so you can attend the previous जो भी faculty आपको classes ले रहा है, they will take every day 1 lecture in the timetable with the digital board. So for you this lecture availability तो रहेगा ही रहेगा, तो जल्दबाजी में सेंटर मत चेंज करना. Wait
Okay,
till 1 week before 1st of February.
ओके सर, थैंक यू सर।
Then we'll have a better idea.
ओके सर, थैंक यू सर।
So,
बोलो.
so what's the answer of this sum?
है नहीं यार मेरा पास, because exercise टेक्स्ट बुक देख लो, बुकलेट देख लो आप, because मेरा पास पीडीएफ में सिर्फ एक्सरसाइज है, आंसर्स है नहीं.
All right, sir. Thank you, sir.